Okay, in this part, we would like to discuss about the multiphase simulation using the VOF or volume of fluid model. So, why I include this tutorial in this course, because it is like like lots of engineering problems consisting of more than one phase. Let's say if we want to mix some mixtures, or maybe designing a mixing tank, or maybe to simulate the drag of a body on top of the wave, let's say for the vessel or maybe ships, then we need the multi-phase simulation. And it is also common case in the chemical industry. So in this part, I would like to copy and paste the tutorial folder, which is the incompressible VOF from the dump brake model. So you can just copy and paste this, and let's say we want to make a new, or maybe just paste here within your project folder. Then let's check what is inside this folder. So basically, the main difference between the multi-phase and a single phase solver or case is the value of the alpha. So alpha basically is like a volume fraction. This is used for the VOF or volume of fluid model. So we have more than we have a lot of choice to use the multi-phase model, let's say for the Eulerian and also the VOF, but maybe the most practical to use, or maybe for beginner, is to use this VOF. So the alpha itself is defined by value of between 0 and 1. So it describes the volume fraction of the fluid. Let's say we set the alpha of water is 1, it means that it is like 100% of water. So if we have like alpha of air is 1, it means that it is 100% air. So let's say for this example, we have like water and also air. So if the alpha of water is 0, it means that it is 100% air. And with the VOF model, we have also like something in between 0 and 1. It means just it's like like the free surface of the model itself. But for some cases, let's say if we want to simulate some diffusivity of one phase to another phase, sometimes we also need some value between 0 and 1 to see the concentration of the mixture. But in this case, we use two extremely different density fluids, which are air with 1 kilogram per meter cube and water with 1000 kilogram per meter cube. So the value of 0 and 1 and everything in between this means that it is like the free surface of the water. So let's check what is inside this alpha water. We have the value of 0, means that in the beginning of the simulation we will use air everywhere, or maybe we just before go there, let's check what is the geometry looks like. Just go to the project folders and dump brake, like make the block mesh. As usual, touch foam.foam to check the mesh in the para view. And let's just drag and drop this foam.foam to the para view to see the geometry. Here we go. So the scenario will be like we have some water here with some certain size, and then we let the air flows goes down to mimic the motion of the break of a dam. So it means so that's why it's called a dam break. But to define the initial condition of the water itself, we use the set field dictionary. Or maybe to understand that, we can open this all run in the notepad, let's say, to see these. Yeah, so first we run the block mesh, which already did. Then we use the set field. Let's check what is set field. So we have the set fields dictionary. This is actually define the alpha water 1. It means like everywhere will be, or everywhere, or I mean in this bounding box, this coordinate will fill with volume fraction of water of 1. So let's just check this by running the set fields. Yeah, it's already set within this box, and just touch again. Let's try to reload it again. And oh, I think we cannot see here now, but it's okay. Okay, then or maybe I should delete it and drag and drop here again to reload the file. Oh, I think it's okay. Let's check it later. Then the next step is to actually run the simulation. Application means that it is like a foam run, so just do the foam run to run the simulation. But while we are running the simulation, let's check the other setup that may be different. So the only different that may be important is the alpha water. The other is just like usual. And let's check the sorry, maybe this one is, yeah, the constant folder. We also see the gravity, so because it is involve motion of the water due to the gravity, we also need the gravity here. Then phase properties, we also need the phase properties to define the only the air, but here we get two physical properties with the extension of dot air and dot water. So we define our mu or nu here, the kinematic viscosity and the density within this physical properties folder. So it is 1000 for the water file. And maybe we also check the phase scheme here, that we must make sure that we calculate the alpha here for the calculation of the alpha or the phase or volume fraction. Yeah, we also have here the alpha water, which you must input, and maybe the control dictionary. And you must note that for the VOF simulation or multiphase simulation, it is very prone to the error from the current number. So we use the modified time step, which, you know, like constrain the maximum of the current number become 1. So if the time step is become too large for the current number, because current number equation is you know, like the function of the time step, mass size, and also the velocity or local velocity. So if the time step is larger, the current number is also become larger. then if the current number too large, which means the time step large, the simulation will become error. So by running this adjustable time step and constraining the current number to be 1, so the time step will be automatically decreased. And this is also the same thing, which is the alpha of the current number of the alpha, and the delta time. If the current number become lower, it means the time step is become larger, and we can set the maximum time step to avoid the time step that is too large, which is also not beneficial if we want to, like plotting the good animation or graph over time. That's why by increasing the delta t, the OpenFOAM wants to make the simulation more efficient. And here we go, we've finished our simulation. Let's just check again by using touchfoam.foam and reload the files again. And here we go, we get our alpha water, which means the volume fraction of the water. And let's go back to the first time steps here. Here we go, it means that at time near the 0, this box was defined using the set fields of volume fraction of 100%. Then over time, due to the gravitational force, the simulation will be spreading the flow like this because of this obstacle. And here we go, our multiphase simulation.